All right. Good afternoon, everyone. Welcome to Ignite. Nice to see you all here. There's a few people here, so hopefully everyone can hear me okay. Welcome to success stories of moving to Microsoft Azure. So basically, this is my chance to tell you about a few of the systems we've successfully moved to Azure over the course of the last year or so, to really drive home the point that you can really move anything you want to Azure, even if it's not something new, which is one of the stories we're going to talk about. So one of the migrations, or the three migrations rather, that I want to talk about here are an in-center data move to the Azure Platform as a Service offering. The second one I want to talk to is one that one of my coworkers did, which was we moved an entire colo from the physical world up to the Azure Infrastructure as a Service offering. And then another one we did, we set up a brand new environment for one of our clients that's a SaaS offering. We're going to pretend they don't exist. That's a SaaS offering that this customer sells to their customers, and we move them to the Azure Infrastructure as a Service offering because they didn't really have an offering that was going to work for this specific client, and this client wasn't really ready to move to Azure, but their sales guys sold something to one of their customers, so they had to come up with a solution fairly fast. So we're talking about that as kind of our third option there. So the first one we moved. This is a data center migration into the Infrastructure as a Service offering. So I was brought into this customer because they hadn't upgraded their servers in a long time. And by a long time, I mean they were buying spare parts on eBay for their servers. Their SAN was woefully out of date, but still under support from their vendor, thankfully. Never seen that. Awesome. They hadn't paid Microsoft any money in 12 years. So we obviously needed to fix that. So this was a migration we finished up at the beginning of last year. Their newest technology in place was Windows 2003 R2 and SQL Server 2005. That was the new stuff. So that should give a general frame of where we were at. So I talked about a lot of this already. So the only thing they really upgraded on a fairly regular basis was their networking switches, their networking environment, because they had to. Because if they didn't, their end users would actually lose connectivity. So they had to keep those up to date. Everything else pretty much was just ancient hardware. This was a fairly small footprint environment. They had about 4 physical hosts, all running Zen as their hypervisor. And they had about 20 or 30 VMs running within that environment that we had to worry about and migrate. This customer has only a few customers, but their customers are companies like Ford, Chevy, GM, those sorts of clients. So obviously their end customers were companies we had to keep happy as part of this migration. Their source software, obviously an open source software. Like I said, everything was Windows 2003 R2, x86. So we didn't have any options as far as moving stuff to Azure, other than just build from scratch, because nothing could be migrated since Azure wasn't going to support any of our x86 platform. We had SQL 2005 in-house. We had SQL 2000 in-house. The other thing they had in-house that we had to worry about was what they used to make their money, and that was AX3. So that was about 14 years old, give or take, when we were doing this migration. And it had been out of support and end of life for about 9. So part of the problem, their host rate capacity, they needed to add more. They wanted to add more lines to their business because they weren't going to be able to survive just dealing with cards anymore. And the environment couldn't support a single host failing. If anything failed in their environment, and their environment's all ancient, the whole thing goes down. So obviously this is a bad place for a company to be in. So we had to do something about this. So we were brought in to do 2 specific things for them. Look and see if we should buy new servers and what we should buy, or should we move to the cloud. So we had to present 2 options to them to see which was going to be the better option for them to use, and then we actually do that migration and do that moving. So we presented both options. On paper, both looked about the same. One of the reasons they really liked the cloud option, or the COO really liked the cloud option, is because it would force his executive team to keep paying the bill. If they wanted to keep the company alive, they had to pay Microsoft every month. If we bought things on-prem, there was no guarantee they were going to pay for software assurance when their software assurance cycle was over, and there was no guarantee they were going to buy hardware every 3 years or every 4 years as that hardware needed to be refreshed. So what did this migration look like? Since we literally picked up their entire office and moved it to Azure. So obviously we built some new VMs in Azure, and we rebuilt everything from scratch in this particular case, because there was nothing we could move. Obviously all those Windows boxes couldn't move, so they had to go to Windows 2012, because that was the newest thing available at the time. And then all our software and all our applications had to be manually installed on the new platform. So one of the really neat things we were able to do is, because things like Microsoft AX was so old, it didn't know it wasn't supposed to work in Azure. It didn't know it wasn't supposed to work on a SQL Server availability group. So we were able to utilize all this functionality to get them all their HA they wanted and move everything to Azure without the applications complaining that they were being moved, because the applications didn't know any of this was going to exist, because the apps were just simply too old to actually know there was a problem. So SQL did need to be upgraded, because we couldn't use SQL 05. I mean, we could have installed it, but it was already out of support, and everything was going to work on SQL 2014. So we did go ahead and do that. And so we actually did this as a SQL availability group in the Azure environment, so that we could actually point the application to that and use that for this old AX environment. And it's been working great, knock on wood, for about 1.5 years now. So, like I said, AX doesn't really know it's in an availability group, but it is, and it works fine, and everything's working because it doesn't need any of the features that weren't there, because it doesn't know any of those features didn't exist. Now, to obviously do this migration, we couldn't use any of the newer technologies available to us. So we couldn't use availability groups. We couldn't use hard disk mirroring, because we're going platform, we're changing platforms. We're doing a lot of changes as part of this process. So we actually fell back to using good old-fashioned SQL Server log shipping to do this migration of the actual databases. So the app servers are fairly small. They're fairly easy to migrate. We're just doing application reinstalls for those boxes. For the actual SQL servers, now we're talking 0.5 terabyte, 0.75 terabyte of data. So it's a good amount of data to deal with. Once we got it all up there through our backup and restore, then we can do log shipping and keep that up to date and keep that box current until we were actually ready to do that failover. The database itself was failed over in about 10-15 minutes of actual outage to the application. So we simply swung it over, made sure it was working, down the old database, and then repointed the DNS name over to the new box, and things just kept working. So we could move the database and then worry about reconnecting the applications to the new name. So the end result for this specific client, all our VMs are running SQL Server 2012 R2. Everything was a fresh install. All our services were deployed and very easily to upgrade, because we were able to push everything out very quickly and easily. All our SQL processes were moved to SQL 2014. Now, a few of them were actually moved from SQL Server 2000 to SQL Server Azure, so Azure SQL Database. So we actually did the largest upgrade we could do at the time, because we were able to move that far. All our high availability within SQL is done by availability groups. All our high availability for our app servers or for our web servers is handled through load balancers and scaling things out, just like we're all supposed to be doing. We did set up availability sets so we can have high availability within the Azure environment. Once availability zones are introduced into the region we're in, and this particular environment is in US West, we'll go ahead and switch these boxes out to using availability zones as well, and getting more high availability as part of this process. The biggest win for the executive team is we gave them a quote and said, this is how much we think this is all going to cost. We actually were able to bring this solution in at about 70% of what we thought it was going to cost. So that was a huge deal for the CFO and CEO because they like saving money. And this is a privately held company, so it's literally the CEO's money that we're saving there. So, second option here is a co-location that we did, that we actually went ahead and moved to Azure. So we moved dozens and dozens of VMs to Azure to do this migration. So this migration was a fairly large footprint of about 50 terabytes in total that we had to move up to Azure to make this migration work. Some of these VMs are running Windows, some are running Linux. Obviously, those are all going to work very, very well in the Azure environment because we can run them all without any sorts of problems. On-prem, our old boxes were physical SQL servers. So obviously, those were going to VMs, so we had to figure out exactly which VM size was going to be the right size for these boxes. Two of the big problems we had when dealing with these was the fact that we had legacy file server clusters in place, so we had to figure out what to do with those. So those were our part of our SQL Server environment. The other thing we had to deal with was large amounts of RAM and very small CPU counts. Because we didn't need a lot of processing power, we needed a lot of RAM for these very, very large data warehouses that this customer has, because this customer sells data. That's the whole process that they actually do. So what we ended up doing was using the constrained cores that are available in Azure to actually reduce the number of cores we present to the VM. That reduces the number of cores the client had to then license for SQL Server, since SQL Server obviously is not an inexpensive product to license. So we were able to use I believe the GS5 -4s, or -8s rather, to actually reduce the core count, but keep all the memory. So we still pay for the Windows license for those cores that we're not using. Who cares? That's a small amount of money, considering how much SQL Server Enterprise is going to cost us. And we were able to license it on 8 cores instead of the 32 cores that actually come with that size VM. So like I mentioned, our total data size was about 50 to 60 terabytes. Now we did cheat a little bit in this environment because we didn't move their backups. Basically what we did is we installed everything new, we set everything up in Azure in the new environment, we took backups of it, and the business decided, you know what, let's just throw away the old stuff, we don't need that anymore. If we had migrated the backups, we would have been looking at another couple hundred terabytes worth of data to actually move. And they weren't willing to spend the money to do that because their express route was already full for doing this migration and with just regular data being sent up. So again, we used log shipping to actually do the migration because that was the easiest way for us to get this data from point A to point B. And again, because we're doing version upgrades as part of this process, and we wanted to be able to set the database up, stand it up, let users hit the database, and then run queries against it, and then tear it all down and restore it again. So log shipping ended up being the easiest way for us to do that without having to break a mirror and reset it up every single time. All our app servers, again, were reinstalled simply because we wanted to be able to do server name changes and actually set a naming schema for this client because this is a homegrown application. So all our servers' names are based around, I believe, comic book characters in the old environment, and we needed to fix that as we went into a newer, larger environment that had more server names. So our public cutover was actually fairly simple because, again, the public just accesses them through a web page. So all we did was point the old web servers to the databases and then swing DNS and let customers just migrate over the course of the next day or two as they needed to. We did all this over a weekend, so the customers were fairly minimally impacted to begin with. Any customers that were hitting the old servers come Monday, things were just a little bit slower, maybe half a second slower, a second slower, because that network connection was going across the link as we figured out what they were doing and what customers were on that old server. Internally, we failed everything over again fairly quickly. We were able to set up our DNS to simply point the old names to the new servers, so if there were users that were connecting to those old names, they were able to simply keep using those names to connect to the boxes and keep things working, because that was our end goal, was to simply keep everything working. So our end result, obviously, everything migrated to Azure, and more importantly for the customer, the colo was closed. So the main reason they wanted to do this migration was for two reasons. One, the cost of their storage in Azure was the same as their entire colo bill, so that was the first reason. The second reason was because of the colo, they had 4 production outages in a month. So the colo would just randomly take LUNs away from VMs or take LUNs away from production clusters. So, and at one point they actually cloned a LUN, and we started deleting stuff off the clone because we thought it was a copy, and it was actually just a snapshot. It was supposed to be a clone. So obviously a few production issues there that were introduced. So that was the other big reason we wanted to do this migration. So this customer does have some more work to do. One of the things they're going to do is review everything that just came out today and is coming out this week, because this customer might want to use some of those new features. This customer actually used 2016 long before it was in production for SQL Server. So they are very interested in new features that are coming out and new applications they can build as part of their infrastructure. They've been evaluating managed instance, and they're going to keep doing so and keep looking at that and moving some of their VMs to the PaaS world and going towards managed instance, as managed instance is going to be able to support some of these large databases that they have available to them. And then obviously they're going to be looking at some of the new features that were announced today and that I think are also getting re-announced at about 2 o'clock today, where they're going to be evaluating the larger database sizes that are now going to be available in SQLDB. If you haven't seen that yet, definitely check it out. So the last migration I want to talk about is a SaaS application that we moved to Azure VMs. Now the reason we moved to SaaS application is because as far as the end customers are concerned, it's a SaaS application, but it was never meant to be a SaaS application. So they were thinking about building a cloud solution because everything was hosted on-prem at the customer's office before this migration started. The whole reason we ended up building them a cloud solution is because while they were thinking about this and talking about it internally, one of their salespeople got wind of the fact they were thinking about doing this, and he sold this deal to a customer. So they had to come up with some sort of cloud solution in about a month because they had a contract that had already been signed with a client. So they obviously had to get this, this migration done. So, like I said, the app was built for self-hosting, and the end users are hospital employees. So we have a magic phrase that we have to deal with in the hospital world. It's called quality of care. As soon as that phrase gets mentioned, everything gets dropped in it. You have to work on this to make it work. So these end users, the end customers, because they are hospitals, they have huge, huge amounts of data. We just did a migration a couple of months ago for one client of about 100 terabytes of data into this environment in Azure. So in total, this customer is hosting somewhere between 0.5 and 1 petabyte of data in the Azure environment. So not a small footprint. So because this was basically a new environment, we were actually able to build it from scratch. So we'll do a lot of fairly cool things in Azure, specifically for this app. Obviously, all our environment is virtual machines because it is this kind of legacy style environment. Everything is set up with load balancers. Not everything is highly available. That was just a business decision on the customer's side. As they add more and more customers and as they set up more and more systems in this environment, they'll set up more and more high availability. But we wanted to be prepared for that. That's one of the nice things about Azure is if we spend a little bit extra time up front, we'd actually do we can set these things up so that high availability is already built into them. So when we're ready for that high availability, we just build new web servers, install their software. Once they're ready, just add them to the load balancer and we're done. All of our SQL servers are failover clusters just because the application itself doesn't support anything else. They're working on an availability group option, but their developers are what I like to call extremely slow. I started working with this company 4 years ago. A request I made the 3rd week I worked with them just got fixed. And it's been 4 years. So they're not exactly fast at adding new features for me. They have a fairly large file server cluster. It's about 35 terabytes in Azure. Right now, because it is an older environment, these are a bunch of 1 terabyte hard drives. So I'm probably going to change that. Now we have these nice new 32 terabyte hard drives available. I can now present 1 disk to the VM, and I can go with a smaller VM size and save this client some money every month because we only have 1 hard drive. And the whole reason we have larger VMs for our file servers is because we need to present 32 disks to the server. We are using legacy storage accounts for this client and not managed storage. Now, the reason being is because we have all these file servers, or all these disks attached to the VMs, and because of that, we're getting enough I/O to do what we need to do. Because again, we've got 32 drives attached to a single box, so 32 times 500 is actually a decent amount of I/O that the machine can present itself when we need to move files around. As we go to 1 disk, we may need to rethink that. We may end up going just towards managed storage. Some of our customers do have ExpressRoute in this particular environment set up because they need that low-level latency that ExpressRoute is going to provide to go from their on-prem environment to Azure, so the end users actually use the application are able to actually utilize it and get what they need out of it. Each of these customers, our end customers, is going to have their own VNet in this particular environment. We've done some really interesting work to actually set VNet to VNet peering so that we can get the end users able to access some servers and not others, simply because the VNet will not allow them to go across that peer because they're coming in via either a site-to-site VPN or an ExpressRoute. So the end result of this environment is we do have high availability where we need it in the few places that we do need it. Most of those are the back-end services. The end customers aren't particularly concerned about their individual environments that they have access to being highly available. We have the performance where we need it, because again, we're simply paying for what we need when we need it. Most importantly, the end users are happy with the environment, and they're happy with the solution we're providing, and so are the customers. My customer is happy with the environment that I'm providing them. Obviously, that makes me happy. The CEO of their environment was very happy with the solution about a month and a half ago, because he actually told them to specifically tell me that he was very happy with what we were providing and the entire Azure environment that we'd provided to their end customers, because it was working. One of the important things is, because this is medical data, we have to make sure that we can provide isolation of the environments. And we've been able to do that by having each individual environment separated from each other by VNets where we need to, so the end users cannot talk to each other and they cannot talk to any of the core machines like domain controllers or SQL servers directly from those end environments. All of this entire environment, whenever we set up a new client, we're setting up about 8 VMs. That's all done through a single JSON script called through PowerShell. So all of these VMs, all of this environment to get set up takes about 20 minutes to get set up, because there's a bunch of questions that get asked at the beginning of the PowerShell. The JSON then runs, and a new environment is then deployed. About 20 minutes later, they can my customer can log in, they can set up their environment, and they can install their software, do whatever they need to do, and it's handed off to the end customer to do their professional services work that they're doing for their end customer. So the biggest thing about Azure that you'll see as you're deploying Azure and as you're talking to people about Azure deployments, no 2 deployments in Azure are going to be the same. Every single deployment is different, simply because we all have different requirements of what we're going to build. Now these are all 3 fairly big environments. They should be fairly similar. They're really not, even though they were all built by the exact same people. If each deployment is carefully thought out, it's going to be successful. You can't rush an Azure deployment. That's about the worst possible thing you can do. The really nice thing about Azure, even if you really screw up an Azure deployment and make some really interesting decisions early on, you can fix them. It's just a matter of taking some time and actually fixing those. You can actually fix stuff. And sometimes on-prem, that's a lot harder than it needs to be. All the migrations you do that are rushed, or that you try to rush through just to get done, those are going to have some sort of issue to deal with that you're going to have to deal with at some point. But you can, like I said, you can fix those. So, unfortunately, I am all out of time. If you have any questions, I'll be up here for a couple of minutes. I'll be in the data platform booth over the data and AI section over by the blockchain booth. Thank you all very much for coming. Don't forget to submit your evals for the sessions. You can download the app and go to the website. Thank you all very much.